So as I said, my name is Ola Wiberg. I'm the co-founder and VP of engineering at Human API. And today I'll be talking about building a health data platform for the future. So it's probably a little bit different from some of the other talks that you've been listening to during this conference. So I'll talk more about the infrastructure. How do you actually build the infrastructure to support a big data product versus more code-specific examples or talks that you have seen earlier today. So a little bit about Human API. What are we trying to solve as a company? So our mission is to drive availability of health data and medical data. And today, if you want to build an application using clinical data, for example, it's a pretty difficult task to actually get the data that you need. So we are here trying to solve that problem, to basically be the easiest way to get health data from anywhere. So currently we have integrated with more than 2,000 data sources. We have 10,000 developers on the platform in about 35 different countries as of today. So you can view Human API basically as a new type of health data exchange. So look at it, we have a lot of different sources, thousands of different sources of data, and that data can come from tracking devices like your Fitbit, Jawbone, those type of devices that you wear, or glucose meters that you use to take to read your blood measurements at home, or it can be a wireless scale, those type of devices or apps that you're tracking. So Moves, for example, track your activity, your location, how many steps you take, how much you cycle. But it's also clinical data, so if you go to the hospital and you create a medical record, we can get that into the system and you can share that with doctors. We can also get data from labs. So of course this is a lot better than fax machines. People still use a lot of fax machines and health data today to transport or transfer health records, so sending paper copies around by mail or fax. So we try to make that a lot easier by creating a simple to use API to get access to that data for application developers. And also, of course, normalize and standardize that data to make it easy to programmatically work with that data. And so we would enable, by doing this, we enable basically a complete living history of a person's health data. So that's the long-term vision, of course. Today we only have a little bit of data, a few years of these type of devices, but in the long run, you can build a whole history of your health basically on our platform. And one thing that we see as really important is that the consumer should be in control of this data. So you as a user, you're the one who tells what data to get and who to share it with. So if you've seen a doctor and you need to share that data with a specialist, you should have full control and insight into where that data is going. Versus today, you don't really know the data is shared without your explicit consent. So about the technology, so what does our system do? So yeah, we process a lot of data, and basically there are simple tasks that we need to maintain. So basically having on-demand workers to collect, process, store, and present that data. So we have many sources of data coming into the system, but we only have one API that serves that data. So the challenging for us is that to maintain all these collection services and get the data from many different places and processing it into a format that is usable for application developers. So how do we design a system to handling this at scale? So some of our goals with the system is it should be agile. So we want to be able to develop and move fast. So have a fast develop, build, deploy cycle. And we want self-contained services. So if we deploy something, we want everything to be part of that deployment. So make it easy to deploy applications. And it should be repeatable. Whenever you deploy that application, it should have the same result. And also scalable. So a lot of these integrations need to scale up and down based on demand, batch jobs or load, different kind of load. And we also want a language agnostic platform. So I know a lot of people here are Scala developers. We have Scala, Java, but we also have Node.js and some Python. It can be any language, and we want to have a platform that actually supports any type of language. So how do we build this? So the main building block of our system is basically Docker microservices. So all services in our system run on lightweight containers. So some of the advantages there is that it's self-contained. I don't know actually how many of you are using Docker? Okay, so it's about half of you. So some of the advantages there are the self-contained. So you can specify all the dependencies that is needed to run that container. And you can configure it at build time or runtime. So it's very flexible in that way. And it's very quick to scale up new services as you need it or take them down if you don't need them. And you can run these, like thousands of these Docker containers pretty easy with what we are using. So yeah, how do you manage those services? So we are using Mesos to run those Docker containers. So Mesos is a technology basically, I mean, it's the foundation of our infrastructure. So you can see it as a cloud operating system, an abstraction layer over your hardware on the cloud, basically. So it pools all the resources on Amazon. So we're running on Amazon. So it pools all the resources. We can just add servers. And Mesos abstract the hardware away and just gives us the CPU and memory that we need to run the containers. And of course, it supports Docker for containerizing. And it has great service isolation, so you can dedicate specific CPU and memory to the containers, so it doesn't use up more than it needs. And Mesos system contains of master servers, which are the ones that keep track of how much resources are available. It has the Mesos slaves, which are the servers that actually run all the containers. And it has frameworks, which are basically applications that helps you manage the running containers, the running Docker containers. So just to visualize that a little bit, so on this slide you see there are a couple of slaves. And the slaves basically report to the master how much CPU or memory that is available on that slave. And the small little green dots in the slave, those are the Docker containers. So they're running in the slave, and they publish what they have available to use. So 4 gigabit of RAM and three CPUs free. So they publish that to the master. And the master make that available to the framework. So the framework knows what it can use to publish new tasks, pretty much. And the frameworks can be a number of different type of applications, but what we use is, for example, for deployment, we use something called Marathon. So let's say you want to deploy a service that need 1 gigabyte of RAM and half a CPU. You tell Marathon you need to run that task. So how does that happen? So Marathon is a Mesos framework that manages the running containers. And it basically does things like sets the environmental variables and assigns the requested CPU and memory. and starts up as many instances as needed to run that service. And to manage that deployment process, we have actually developed a command line tool. We call it HappyCo. So that is for deployment and automation. So basically anything that we have encountered as problematic, we have built tools around that just to make this process really simple. So we can just type a command to scale up or scale down a service or deploy a new service. So that CLI, it interacts with Marathon, also Mesos, and Jenkins, which we use to actually build the project and create the Docker containers. So just to illustrate how that works, if we have this, the infrastructure running with the Mesos masters, they're controlled by Zookeeper, and we have a number of slaves here, 9 slaves, and Marathon, that is the framework. And as you see that there is a service A that is available, or it's running on 3 different slaves. So what it does is it tries to run the services on the different slaves just for redundancy purpose. And if you notice that we need more resources at this point, we actually can just issue a command to Marathon, and we tell Marathon that we need to start up another instance. Marathon checks the available slaves and see where resources available, and it finds that slave 5 has some resource available to run the service, and it tells it start up a new service A on slave 5. And now we have scaled up that service, and this happens in just a matter of seconds. So it's really fast to scale up and down services like this. So this is a little bit blurry with this resolution, but the Marathon comes with a web UI, so you can actually control the services through the web, but also the white box in the corner there shows our command line tool that we have developed and how you can deploy with simple commands and specify CPU memory and number of instances you need. So now when everything is running, another problem we had to solve with this platform is minimize downtime. So the API that we are serving is on AWS. We cannot use AWS ELBs. And some of the requirements we have is, of course, that we want to be able to deploy often, like I mentioned in the beginning, so we should be quick to deploy. And it should also be able to scale out easily horizontally for the public services, not just the internal workers. So ELB is a little bit problematic that way because it's kind of tied to one specific port, and Mesos brings up the services with random ports. So if you start up a service, it just assigns a port, usually a random high number port. So what we did to solve that is to use a combination of EngineX Console and confd. So console is basically a key value store, and it's used for service discovery and configuration management. And confd is a configuration tool that is used to basically update config files and execute commands. Pretty simple tasks. And Mesos actually publish all the events that is happening on the system to as a webhook. And for example, containers coming up and down are published as those events. So we are using that to actually control or to configure the system. So when Mesos creates a new service, so we run that Marathon command and start up a new service. So as you see in step 1 here, we create a container. It assigns a random address, and it publishes that event. So we have an internal webhook service that is listening to all those events. So as soon as we get that event, we update console configuration with those service details. And confd is listening for changes in console. So as soon as confd sees that change in console, it just quickly reconfigures EngineX and then reloads. So that service or that container is now available on a public port. So that's a little bit about the containers and how we manage uptime and quick reconfiguration and scaling of the system. So how do I actually handle the data used by the services? So some of our needs is that microservices needs to be able to communicate, and to communicate directly with each other, it's time consuming and hard to manage. And there needs to be a general purpose solution, and we also want to be able to enable easy data pipelining to work with the data, so collect, parse, and persist. And should be able to handle large volumes of data and preferably be durable and ability to replay. So I think this sounds quite familiar to a lot of you. So what we ended up doing is using Kafka pretty much for everything. So is pretty much it's the data pipeline for us, a data backend. So we put the logs in there. We have metrics and heartbeats for the applications, and the containers go through Kafka. Also application events that can be passed to analyzers, and data pipelining jobs. We put the data in there as part of the processing before it's passed on to persisters. And this also gives us a great feature that we can use, like we can replay things. So Kafka allows it, what Jay was showing us this morning, you just point to a specific place in Kafka, in the Kafka timeline, and process the task from that point. And it's also great for auditing purpose. So just a quick picture, but we're running out of time, so I'm just going to skip through and recap. Yeah, Mesos is our foundation. We run Dockerized microservices building blocks. Marathon is the orchestrator to manage the tasks, and Kafka is the main backbone for the data flowing through the system. So that's pretty much it. So thank you. And also we're hiring, like everyone else. So if you're interested in talking more about that, see me afterwards. So thank you.
We maybe have time for just like 1 or 2 quick questions. Is there anyone out here? Okay, this one in the back over here.
So you mentioned that you were using Mesos for mostly the data center operating system idea. Are you using it at all as like a Spark execution engine, or have you looked at that sort of stuff? Or
we haven't used it as that, but yeah, we're looking at it.
Thank you.
All right, one in the front. I'll be right there.
Yeah, hi. I wonder, is any of this tied to the US market, or could it work in, say, Europe?
Yeah, we have customers in Europe as well.
Yeah.
Yes. Yeah, he was asking if this is tied to US market, but we have customers in Europe and other places as well, so not just US. But there are different laws and regulations, different parts. So.
All right, and maybe one more.
So does it mean you spin up a separate instance for each customer of this configuration?
No. So it's more instances for different services. So the integration, the data sources, Many of those run dedicated instances, but not the customers. So the customers consume the data through the API, which is basically just one, I mean, many instances, but it's one API.
So you have security on the API?
Yes.
Okay.
Great. Well, if there's any more questions, I'm sure Ola would be happy to answer those offline. So, but thank you so much,
Yeah.
Ola. Maybe we can join me
Thank
in
you.
thanking him one more time.